Very excited for this event. I'm really excited to give you a demo at the end of this all.
Hi, Luke. Hi.
Hi.
Luke, can you show us around a little bit?
Yes, of course. So what you can see here is our engineers, and on these screens they control what's going to happen with the vehicle.
Yes.
They have sensor inputs, they have, for instance, acceleration, speeds, and those type of things. And among them is the switch. It's very important to know where you're going. It would be a shame to end up in Paris when you're going to Düsseldorf.
That would suck. I mean, big time, right? You've been working on this test facility for 2 years.
That's right.
What was the biggest challenge?
Well, I think there were some challenges. I think the biggest one was working in a small team. We accomplished this feat, I think, with 7 engineers. And
It's
we worked...
not so much.
No, that's
No.
not. We were each of us responsible for quite a big part of it all.
So you worked really, really hard.
That's right. And that's why it's super nice to have all these great partners that could help us in all the pieces where we didn't have the expertise.
And later on, you will show us the scoop of today.
That's right.
And then now we're going to listen to the story of Sascha Lamme about the great breakthrough, I have to say this correctly, of Hard Hyperloop.
He is the Chief Technology Officer of Hard Hyperloop. Please welcome Sascha Lamme.
Thank you. Thank you, Luc. Thank you, Vrouwtje, for your wonderful questions. And it's indeed true that we could only have made this happen with the help of our partners, with the small team that we have. And it's my honor to all of you to today announce the first fully operational Hyperloop system by Hard. And why is this so important? Because this is the first step towards a fully operational Hyperloop network around Europe that will connect every city within 3 hours. However, this would not have been possible by using the current modes of transportation that brought us here today together at this wonderful event. But they also connect us, and by that they allow us to share knowledge. And that brought us the opportunity to develop this brand new system that we can use to address the challenges of today, where we want to travel further, where we want to travel more, where we want to travel farther. And this, of course, pushes substantial pressure on our infrastructure and not only our environment. And that's why throughout the development of this system, we looked at these modes of transportation. We looked at the cleanest, the best, the fastest, the most reliable, and of course the safest modes of transportation, and applied their lessons throughout the development. So let me give you one of those examples. One of the examples is the Japanese high-speed rail, the Shinkansen. This is the safest mode of transportation on the planet, with zero fatalities over its 50 years of existence. Not a single person has ever died using the system. Also, it's very well known for its punctuality. Only have a 30-second delay over an entire year per train. So what makes this system so safe, so reliable? It's that this system was developed by taking safety and reliability as their number one priority from the very beginning. And not only that, it is still their number one priority today during operations and maintenance. And that's how you create a safe system. Because they realized that to make a truly safe system, you need to make sure that nothing can stand in its way. It's because they realized that 70% of the disturbances are caused by external effects, like cars getting stuck on crossovers, or trees, because the weather falling on the tracks. So that is why in this system you will not find a single crossover, and the entire system is elevated or put underground, so that nothing can stand in its way. And applying lessons like these, from not only the trains, but also from aviation, from cars, you name it, made it possible for me to present you today the system that we have come up with. That is why our system is also elevated, or can just as easily be put underground. It is why we have a tube to take at the air to make it possible to travel with 0 emissions. But this tube also protects us from the environment, to prevent trees falling on the tracks, to have a safeguard for the vehicles inside. And it is why these vehicles that we have in these tubes are very lightweight, because using lightweight vehicles that can travel quickly and at high frequencies allow us to make light infrastructure that's agile and can easily be implemented and follow existing rights of way and only requires a very small footprint. It is why our system uses a magnetic levitation system. Because with a magnetic levitation system, there's nowhere in the entire system, and that reduces the maintenance cost to an absolute minimum. It is also why this magnetic levitation system hangs on top, because using this magnetic levitation system, we can do the most efficient propulsion. And of course, it is why our vehicles travel at high speeds, because we have developed such a lane switch, a switch that can connect all of us directly without any intermediate stops. And that's what we test in this facility, among others. We not only test the switch, but in this facility we also test our levitation system, a levitation system that can lift the full weight of a passenger cabin using almost zero power. Also in this test facility we were able to prove the propulsion to accelerate the vehicle and then decelerate it again to bring it to a safe standstill. And in that process, regenerate almost all of the energy to accelerate the next, making the system, of course, extremely efficient. And then, of course, what it's all about today, we tested our lane switch. A lane switch without any mechanical moving components, making it very safe and very reliable, and allowing us to take a lane switch and creating this network at 1,000 kilometers an hour. And that's why this facility is so important, because it not only allows us to learn from all these other modes of transportation and apply those, but also to learn new things, and by that reach our goals of connecting Europe in 3 hours with 0 fatalities, 0 delays, and 0 emissions.
So in the test facility we have in Delft, we are testing every component that Hyperloop needs to operate. We do that at full scale. And the latest we've come up with is the Hyperloop switch. So based on our hybrid magnetic levitation and propulsion, we can actually create connections to tubes that are a bit like a highway, so in which vehicles go on, they join the main line, and then they can go off at any point. This is the beginning of the European Hyperloop network that stretches more than 10,000 kilometers across national borders.
Into this test facility, we have built the 3 core systems of the Hyperloop, namely the levitation, which is the component that allows the vehicle to lift off of the ground, creating 0 friction with the track and remain at a stable distance from it. In addition to that, the vehicle is now able to propel back and forth, which is what we call the propulsion.
So once the vehicle is moving, we use lateral tracks to actually keep it in place. And when we need the vehicle to go from one track to the other, we pull them towards one track. This way we can decide where do we want the vehicle to go. All of these components were tested in our facility at Delft, in which we have a near vacuum environment. Everything is controlled, and we test everything simulating real vehicle weight and size.
What is great about the realization of this facility, that it's not just the work of a single startup, but it's really an ecosystem that has been working together on this. So all of the different subsystems that are being tested in this facility are already co-developed and supplied by partners right now.
Steel is a vital component of sustainable future mobility. Drawing on Tata Steel's high-tech innovation skills and materials expertise, we support the development of Hyperloop.
2 years ago, we started our relationship with Hart. And in the meantime, we have created a working system.
And especially during the whole process of getting this Hyperloop test facility to a finalized project, there were continuously more and more partners adding to help and to make it a reality. I feel extremely grateful about that. Especially the team has done such a tremendous effort to get it finished on time and make everything work. So it's really amazing.
Sasha, this is so cool. And we were